Hi, the PoE Power over Internet allows us to use single Ethernet cable to send both power and data to the edge device. So it's a convenient tool to install the low voltage products such like IP-camera, access point, VoIP phone. However, the PoE is limited to 100 meters. If we need a distance beyond 100 meters, we can use the PoE standard. But eventually, the PoE standard will compromise the speed. What if we need long distance, also fast speed? One of the solutions could be the fiber optic cable. The fiber optic cable can achieve up to 80 kilometers with 100 megabytes per second speed. It's quite long. But there's one issue with the fiber optic cable. Unlike the copper cable, we can inject the power to the Ethernet cable. We cannot inject the power to a fiber optic cable. Technically, it's just a plastic. Is there any workaround? One of the solutions is we can wire the second power cord in parallel with this fiber optic cable. So totally we have two cables. One is the fiber optic cable, the other is the power cord. And sending the power and data from the router. In this kind of solution, we need to deal with one very important thing, is the voltage drop. You see, when we send the power through a copper cable, there are always voltage drop. The longer the distance, the more serious voltage drop will be. Eventually, you don't have enough voltage at the edge to power your device. So there are two things can take care of the voltage drop. One is the diameter of the power cord. If you have too much currents running through, you can choose the thicker copper cable. It can reduce the voltage drop. The other thing is the edge device like this one. This is the outdoor media converter. It has built-in power regulator which can take in the voltage between DC 24 to DC 55 and output the standard PoE. So even there's serious voltage drop, after the power arrives at this media converter, it still can output the standard PoE. Now let me just make a quick connection. First, let's set up the fiber optic cable with the power cord between the first fiber optic terminal box to the second one. This is the factory pre-made fiber optic cable. So I don't need to do the fusion in the field. The LC connector has been built in the factory and 100% test. What I need to do is just wire the cable and plug and play it. And we also need the power cord. This is the cable to send the power from the first terminal box to the second terminal box. So in this case, even there's no power source available at the edge, I still can using the power. First, let me just make the connection for the terminal box point 8. And also the power cable. We need to wire the power cable in parallel. Let's take a look at inside of the conjunction box. The blue one is the LC adapter and the green one just for the power. The fusion plate is still reserved, so if you prefer using the fusion, still can take it. First, let me just install the fiber optic cable. You have to pass through the ground. Now enter the inside of the terminal box. So we're going to put the terminal cable to the adapter. Also, you have to pass the power cord. And now, it's quite important to just have the right sequence. I'm going to put the put the red line on the left and the black one on the right. Alright, now I have just finished the connection for the first conjunction box. Let me just move to the point B. The connection is pretty much the same. I have wired the fiber optic cable and power cable from the first terminal box to the second terminal box. Next, I'm going to add the data and power to the first terminal box, so we can use at the edge by getting from the second terminal box. This is the main router with the data. I will need this media converter to convert the digital signal to fiber optic signal, so it can be traveled through this fiber optic cable. This is the mini media converter. First, let me just power up the media converter. And I also need this short punch code to link the media converter to our main router to get the data. And the next thing is the short punch code we're going to use to link the transceiver to one of the fiber optic cable. We just need to using this short punch code. You may wonder why we need only single fiber optic cable, because this is the BI/DI media transceiver. It's using different wavelength to send and receive the data. So just one fiber optic cable will be enough to sending and receiving the data. So I'm going to get one of the fiber optic cable and just connect to the adapter. The data is ready. We also need the power. We are using this low voltage DC 55 voltage. So first, I'm going to hand up the power data. And now I will just put the power code to the green adapter. So the power will go through this power cable to the edge. It's important to match the positive and negative, otherwise it may just damage your edge IP device at the edge. So I'm going to using the brown to match the red and also the blue to match the black. Now the connection is almost complete. What I need to do is just plug this power code to the AC power outlet. You're not going to see it because it's just not under the camera side. Alright, now we got both power and data ready at the edge. In the next step, I'm going to install the IP device by taking the both power and data from the second terminal box. This media converter can take the data from the fiber optic cable, also the power from the power code. There's voltage regulator built-in, so even there's voltage dropped, the media converter still can output the standard PoE. First, let me just take off the ground. Before we can using this media converter to work with the fiber optic cable, we also need this SRP module. The SRP module will convert the fiber optic signal to digital signal. You can see there's SRP slot, but there's no connector for the fiber optic terminal. This is the one which allows us to use the fiber optic cable. Alright, I'm going to install the SRP module. Now let me just open the terminal box. This is the short punch code, fiber optic punch code. So I'm going to connect the punch code to one of the fiber optic cable to get the signal from the cable. I remember it's just the first one I'm using on the other side, so connect to the first one. And now install the connector to the SLP module. The data is ready, we still need to get the power, right? This is the short punch code just for the power. Let me pass through the ground. It's important to have the right sequence. You see the red for red, the negative for negative. Red is the positive. Okay, the power is ready. Let me just close the box. And now we are going to plug the power to our outdoor media converter. Once we plug in, we can see the power indicator is on, the link is on, which means this outdoor media converter is getting the power and data properly from the back end. So from here, I'm going to using the PoE cable to connect to the Cisco access point. Just a short punch code. Technically, we can still have 100 meters between the outdoor media converter to our edge device. You can see once we plug in, the power just on. Alright, today we have seen how to using the fiber optic cable plus the power cord in parallel to send both power and data to the edge device. Compared with the standard PoE, we can have ultra long distance for fast speed, low latency. That's pretty much for all today's video. If you have any question, you can post in the comment section below. See you next time.